In this video, let's see about Jacobian. It is basically a determinant which is defined for a finite number of functions of the same number of variables and in which each row consists of first partial derivatives of the same function with respect to each of the variables. So what is the application of Jacobian? Actually, it is very significant in evaluation of double integral as well as triple integral of the form say f of x comma y dx dy and all those things. And we are changing by using the transformation from one set of coordinates to other. So it is very simple. Here, if you see, this u and v are functions of two independent variables. This u and v are functions of two independent variables. What are those? X and y. So the Jacobian of say xy with respect to uv, if there is give, okay, now this is nothing but del x by del u into del x by del v, del y by del u, del y by del v, and this is just a determinant. So if you find the determinant like 2 cross 2 determinant, same as this. So this gives the factor by which small volume changes by changing the ordinate system. For example, if I write del of u comma v with respect to x comma y, then I will write del u by del x, the determinant value, and then del u by del y, then del v by del x, and del v by del y. So either uv with respect to xy or xy with respect to uv. Depending on the problem, we'll write the Jacobian value. Let us solve this problem. If u is equal to x plus 3y square minus z cube and v is equal to 4x square yz, w is equal to 2z square xy, then find del uvw with respect to xyz at the given point. So it is obviously to find del uvw with respect to x, y, z. Now we have three variables, right? So it is going to be a 3 cross 3 determinant. First, u with respect to x, we have to write like this: u with respect to x, first row, u with respect to y, and u with respect to z. So u with respect to x, u with respect to y, and u with respect to z. Similarly, v with respect to x, v with respect to y, and v with respect to z. And the last one, w with respect to x, w with respect to y, and w with respect to z. We are going to find all these values, that is del u by del x, del u by del y, and after substituting these values, we are going to find the determinant value. Now let us find u with respect to x. If I differentiate u with respect to x, this 3y square is a constant and z cube is also a constant. X, if I differentiate, only 1. Now same thing, I'm going to differentiate u with respect to y now. So I will differentiate only the y terms. So here x will become a constant, 0. 3y square differentiation is 6y. Again, z cube is just a constant. If I differentiate, I'll get 0. Now same thing I'm going to differentiate with respect to z. So x is a constant, this will become 0. 3y square is a constant, this also will become 0. Minus z cube if I differentiate, minus 3z square. Similarly, v with respect to x. Now it's in multiplication. So 4yz is a constant. X square if I differentiate, 2x. This is for the first term. Again for the second term, 4x z is a constant, 4x square z is a constant. Y if I differentiate, I will get 1 because with respect to y I am doing now. Now the third one is with respect to z. If I differentiate with respect to v with respect to z, I will write 4x square y, and z if I differentiate, I will get 1. So if you see first term, x square differentiation 2x, second term, y differentiation is 1, third term, z differentiation is 1. So we have written the leftover values. Now last, w with respect to x. So 2z square is a constant, 0. X if I differentiate, 1. So minus 1y. This is your first term. Second, with respect to y, so again z is a constant, 0, and then x is minus x as it is, and y differentiation is 1. And the last one, with respect to z. With respect to z means this will become a constant. I will differentiate only z term. So 2z square differentiation is 4z. So now your determinant is ready. We are going to substitute these values and then find out the determinant so that it will be easy. So I'm going to substitute x as 1, y is minus 1, and z is 0 in this determinant. Let me substitute and write. So again I repeat, we are going to substitute x as 1, y is minus 1, and z is 0. So first term is 1 as it is I have written. 6 into y, 6 into minus 1, minus 6. Z is 0, so it's easy. 3z square will become 0. Second term, wherever z is there, happily we can write 0 because it's in multiplication. So first two terms will become 0. Third term, 4x square y. X square is 1, square is 1, y is minus 1. 4 into minus 1 is minus 4. And the last row, minus 1y. So y, if I substitute minus 1, minus and minus will become plus 1. And what will happen to the next term? X, if you substitute minus plus 1, already minus 1 into plus 1, minus 1. And last value, very good for us, z 0. Now it is just solving a 3 cross 3 determinant. What you will do, how you will solve? 1 into, now you will cross multiply, 0 into 0, 0, minus 1 into minus 4 plus 4. This is your first term. Minus of minus 6. So next time I will write it as plus 6. Now leave that 6th row and 6th column. Leftover values, what is that? 0 into 0 is 0 minus 1 into minus 4. Minus 4 you will get. So this minus and this minus will become plus. And the last term, plus 0 into anything is 0. So we are not going to worry about it. Now if you simplify the first term, 1 into minus 4 is minus 4. This is plus 6 into plus 4. So this is 24, this second term, and minus 4 is the first term, which is nothing but 20. So we found the Jacobian value at x is equal to 1, y is equal to minus 1, and z is equal to 0. Otherwise, what you will do if they didn't give any point, just you will solve this determinant which is there above, right? This, we will solve this determinant as it is. If I solve this as it is, what I will write? 1 into 4x square z into 4z minus x into, see, this into this minus x into 4x square y. This minus and this minus will become plus. So like that, minus 6y into second term. And then minus 3z square into third term. Like that, we will do the determinant multiplication. Here they have given you at the point, so it's better to substitute the point first and find the determinant value. Here in this problem, they have given u, v, w directly in terms of x, y, z. So it is easy for us. See here. U is given in terms of x, y, z directly. So it's easy for us to write del u by del x. Suppose if they don't give directly, then we have to find out one in term of other, and then we have to find out the Jacobian value. Let's solve one problem based on that. Now see this problem. They have given x plus y plus z is equal to u, y plus z is equal to v, and z is equal to u, v, w. And they are asking x, y, z, that is x also in terms of u and v, w, y also in terms of u, v, w, z also in terms of u, v, w. Now if you see, only z in terms of u, v, w is matching. So z is ready for the problem. But here x and y I have to get it ready in terms of u, v and w. Otherwise we cannot find out directly. See here, x, y, z by del u, v, w. What is the formula? The previous one if you check, it was u in terms of x. Now here it is x in terms of u, x in terms of v, x in terms of w. See here, x in terms of u, x in terms of v, x in terms of w. Similarly, y in terms of u, y in terms of v, and y in terms of w. Let me complete the determinant. So I have written z also in terms of u, z in terms of v, and z in terms of w. This is done. Now I cannot write simply x is equal to minus u minus of y plus z, because I want x in terms of only u, v and w. I don't want this y plus z. So what is y plus z in the second equation? V. So I can write it as x is equal to u minus v. Now this is ready for solving the problem. X is equal to u minus v is ready. Already z is equal to u, v, w is also ready. Now second thing, I have to write y in terms of the other two. So what is y? V minus z. What is z? U, v, w, right? Y is equal to v minus u, v, w. So you can take v common and you can write this y in terms of the other, or you can keep that as it is. Now all the values are ready for calculation. Now I can directly use this determinant, x in terms of u, x in terms of v, x in terms of w. Let me write that. So if I differentiate x in terms of u if I differentiate 1, v if I differentiate 0. See, very simple. Del x by del u means I will differentiate only u terms. Anything other than u looks like a number for me. So it's just a constant. If you differentiate a constant, what you will get? 0. Now see, same x with respect to v. If I differentiate with respect to v, then this u is a constant. If I differentiate a number, 0. And then v if I differentiate 1, 0 minus 1 minus 1. We can write it directly. And the last one is, if you check x with respect to w, is there any w here? No w. So u is also a constant, v is also a constant, then I will get 0. So now similarly, y with respect to u, v, w we are going to do. Y with respect to u means this is a constant 0, and then v, w is in multiplication. So I will write it as minus v, w. Okay. Then what is the second term with respect to v? V differentiation is 1. So I'll write it as 1 minus, again v differentiation is 1. Then I will write uw. Again last one, y with respect to w. Then first term v is also a constant, and then minus uv. Because w if I differentiate, you will get 1. Last, this is very easy. With respect to u differentiation is 1. So I'll write vw. Second one with z with respect to v means I will write u and w. Then z with respect to w means u and v, because w differentiation is 1. Now we are going to find the determinant value and we have to simplify it. Let me write the determinant value. See here, 1 into this, that is uv into 1 minus w minus this into this, uw into minus uv. Okay, this minus sign is in the determinant. Again, minus of the second thing is minus of minus 1. So minus of minus 1, it will become plus 1. Now, if you cross this row and this column, what you will get? uv into minus vw. That is what we have written, minus vw into minus uv. We have written that. Last 0 into anything which is 0, so no issues. We are just going to simplify these terms. I'll write it. If I multiply 1 into uv, it's uv, then minus u into vw. So 2u is there, so u square vw. Third term, this minus and this minus will become plus. There is 1u, 2v, so u v square w. This term minus v, 2 times v is there, so minus v square uw. Last term, this minus and minus will become plus uv square w. Now if you see, all these terms will get cancelled and you will get finally uv. So you have to be very careful when you are solving the problem, whether it's given directly in terms of one in another. So here we just converted and then we have solved it. And if you see here, this term is v square, this and this will get cancelled, and this will get cancelled. Thank you.